right, video number 2, we're going to be talking about concentration. You are going to need your calculators and your periodic tables, and we have a lot of formulas that go in this particular unit. So when we're talking about concentration, we're looking at how much solute is dissolved in a specific amount of solvent or in the whole solution. And you can look at it qualitatively, so descriptively you can have a solution that's concentrated or a solution that's dilute, or you can actually calculate the concentration using all these various descriptions. So we're going to go through an example of each one. I'm going to show you how to use the formulas for each of them. All right, so the first one we're going to look at is percent by mass and percent by volume. You see these a lot used in household items, like hydrogen peroxide, for example, is 3% by mass. So that means there are 3 grams of hydrogen peroxide per 100 grams of the whole solution. That means the other 97 grams are water. You could do the same with percent by volume. So in our example, we have sodium chloride in an aquarium. It says, in order to maintain a sodium chloride concentration similar to ocean water, an aquarium must contain 3.6 grams of NaCl per 100 grams of water. And we want to know what is the percent by mass of NaCl in the solution. So to find our percent by mass, we're going to take the mass of the solute, which in this case is NaCl, so 3.6 grams of NaCl, and we want to divide by the mass of the solution, and we're talking the whole solution together, which is the solute plus the solvent. So our total mass is 103.6 grams. So you can see our grams cancel, times 100, and that's going to give us 3.5% NaCl by mass. Okay? All right, our next way of expressing concentration is using molarity, and this is the one that's most common in science. This is the one we're going to see for the rest of the year in chemistry. You're going to see it in AP chemistry. You'll probably see it in AP biology or environmental science. This is the one that's most common. And molarity, which is represented by a capital M, is moles of solute per liter of solution. And it's the whole solution, not just the water, but the whole thing. And then we can also relate this dilution equation. So if you have a solution and you want to dilute it and make a new molarity by adding water to it, we can calculate how much we need using the dilution equation. And we'll see what that looks like in our example. All right, so for our first example, calculating molarity, we have a 100.5 milliliter IV solution contains 5.10 grams of glucose. What is the molarity of the solution? Well, if we want to calculate molarity, we need to know moles of the solute and liters of the whole solution. So we're going to have to do some converting here, okay? So our solute is glucose, but we're given grams of glucose. We want moles of glucose. So we're going to have to use that molar mass to convert our grams to moles. So 5.10 grams over 1. 1 mole of glucose has a molar mass of 180.16. They tell us here, or you could add it up from the periodic table. So that gives us 0.0283 moles of glucose. So that's what goes in the top of our equation, 0.0283 moles. Now we want to divide that by liters of the whole solution. Well, we're given milliliters here. So to convert from milliliters to liters, we divide by 1,000. So we have 0.1005 liters. So when we divide, we get 0.282 capital M for molarity. So we would say it is a 0.282 molar solution, or the molarity of the solution is 0.282. All right, for our next example, we're going to use that dilution formula. And if we remember, the dilution formula is M1V1 equals M2V2. Okay, so our M's in M1V1 are molarities, and our V's are volumes. So in this particular formula, the M1 and the V1, those are the molarity and volume of a stock solution. And a stock solution is a solution that you have, it's usually concentrated, that you know the molarity of. And we're going to take a small volume of it, and then we're going to add water to dilute it. So in our example, it says, if you know the concentration of volume of the solution you want to prepare, you can calculate the volume of stock solution you will need. So what volume in milliliters, that's important, of 2 molar calcium chloride stock solution would you use? So we're solving for V1. Our M1 is 2.00 molar. So how much stock solution would you use to make 0.5 liters of 0.3 molar calcium chloride? So the M1 and the M2 and the V2 are the molarity and the volume of the new solution you're trying to make. So our M2 is 0.300 molar. Our V2 is 0.50 liters. Okay, so we solve for V1 and we get 0.075 liters. Now the question specifically says in milliliters, so we want to convert our liters to milliliters by multiplying by 1,000, 75 milliliters. All right, our next formula is to calculate molality, and molality is used in one very specific part of this unit that we'll see later on. Molality, which is represented by a lowercase italicized m, moles of solute over kilograms of solvent. So just the water is going to be on the bottom, not the total. So if we want to look at our example, it says, in the lab, a student adds 4.5 grams of sodium chloride to 100 grams of water. Calculate the molality of the solution. Well, we have grams of both things, and we have to know which is which, the solute and the solvent, to know which way to convert. So our sodium chloride, because we have less of it, this is going to be our solute, and then the water is going to be the solvent. So that means we have to convert these grams into moles and these grams into kilograms. So to convert 4.5 grams of NaCl into moles, we need to know the molar mass. So from the periodic table, we add up the molar mass of NaCl. 1 mole has a mass of 58.443 grams. So that gives us 0.077 moles of NaCl. And then we have 100 grams of water, which is equal to 0.100 kilograms of water. So our molality, we want moles over kilograms. 0.077 moles over 0.1000 kilograms of water. And that's going to give us 0.77 as our molality. Okay. All right, now the last way we can express concentration is by using mole fraction. And a mole fraction is just a ratio of the number of moles of solute in a solution to the total number of moles of solute and solvent. Remember, it's a mixture, so we're looking at a comparison of moles. And we represent mole fraction with a capital X. So XA is the mole fraction of substance A, and you can see it's moles of A over total moles. And then the mole fraction of B, moles of B over total moles. Okay, so it's kind of like a percent, but it's not times 100. It's just a fraction. So if we have a solution that's 22% by moles HCl and 78% water, then the mole fraction of HCl is 0.22. The mole fraction of water is 0.78. Okay, so we're looking at it kind of like a percent, but not out of 100, just out of 1. So it's a ratio of moles. All right, so those are all of our formulas we're going to be used to calculating concentration, and you'll know which one the question is asking for. We will be using the molarity formula most often, so that's the one we're really going to focus on, but we will be seeing all of the others in class.